Works2 Real-Time Log Viewer. Hi everyone, my name is Jaden and I'm an employee at Adroit Technologies. Today, myself and Nathan will be presenting the Log Viewer function within Works2. I'm doing the first half of the presentation, which includes information on what the Log Viewer does, and Nathan will be presenting a demo of the Log Viewer to demonstrate how to set it up and how it works. Please note that this is a pre-recorded presentation, and if you have any questions, feel free to ask them at the end of the presentation, or alternatively send either myself or Nathan an email, and we will get back to you with the appropriate information. Purpose: the GXWorks2 Real-Time Log Viewer is a tool used to record data from a device and then display the data on a graph to allow the user to fault find. For example, let's say that we have a temperature sensor on a tank to allow us to record the current temperature of the water within the tank. We can set up the log viewer to log the temperature of the water over a certain period of time. We can then go back and look at the graph to see when and what time the water changed temperatures. The log viewer is very helpful as it has different settings to allow the user to either log data continuously, which will continuously log the data regardless of the values the device is outputting. Trigger logging, which only logs once the trigger has been met, or there is specification period logging, which allows the user to log data when a specific condition is met. You can also use this data as a backup for a SCADA or an HMI. So if you do have a SCADA system or an HMI somewhere and you lose comms to that SCADA or HMI, you can always use the data that was logged as a backup. Devices. Devices will be the things that you will receive the data from. An example will be a thermometer. The data will then get put onto a graph using the log viewer. When they talk about devices, they're referring to the registers or the addresses in the PLC. So your bit devices that you can log are your X, M, Y, L, and so forth. There are a lot of them that you can actually use. Configuration. This is where you'll then specify the sampling interval and start conditions for the real-time log viewer. There are various different sampling intervals that the user may choose from. Sampling. This is where you specify the interval and start conditions for the log viewer. Each scanning cycle. There is an option called each scanning cycle, which only samples data at each sequence scanning cycle. So every time there's a scan through the PLC, it will log this data for you onto the PLC with the logging configuration and an SD card. The each scanning cycle will sample every time you have a scan, so at the beginning of the scan, not at the end. It will then log the sample to the PLC, as seen on the screen. Time specification. This is a specific time interval. The shortest time that you can do is 10 milliseconds, and it goes up to once a minute or even once an hour, but it depends on the application and depending on how quickly you want to log your data, so it's ultimately your decision at the end of the day. The time-specific data capturing, which only logs the data at specific time intervals, so you can specify that you want it to log data from 8 a.m. to 8 p.m. and the graph will represent the data accordingly. Viewing logged data. Logged data can be exported as a CSV file, which can then be viewed in Excel in the following format, as seen below. The program that we use to demonstrate only consists of one analog, which was turned in a clockwise direction to increase the value to a specific number. Once that number is met, it will be logged with a timestamp to specify the time and date of the occurrence. Additional information and features. Operating procedure. Select the upper end or the lower end of the graph with the mouse and drag it towards the upper or downward side of the graph. Moving graph. Select a trend graph with the mouse and drag it upward or downward. Time scale settings. The time scale can be adjusted by scrolling the wheel with the control key held down. Scrolling the mouse wheel up expands the time scale and scrolling it down will reduce the time scale. Graphs can be adjusted easily by using the automatic adjustment function, as well as the drag and drop operation. Data can be verified quickly since graphs can be adjusted intuitively and spontaneously through the use of a mouse operation alone. Logging data stored in multiple files can be displayed within the same graph area to verify the differences between the respective data with the same time intervals. Overlapping graphs using simple operations makes it easy to compare the data of different files. Thank you for your time. I will now be handing it over to Nathan.
Hi everyone, I am Nathan and I am a junior Droid Species Support Engineer. Today I will be presenting the GX2 real-time log viewer demo. Firstly, I'm going to create a new program. I'm going to be saving my program as example1. I'm going to rename my program here as well. Now I'm going to set my parameters. The first parameter I'm going to set is the remote reset. I'm going to allow it. The next parameter is I'm going to insert a program to be scanned. Next I'm going to set my internal relay from 15k to 9k, and I'm going to set my data register from 22k to 13k. For the IO assignment, I'm going to create a input called QX80. I'm going to make the start YX000. Next I'm going to create an output which is going to be called QY10, and I'm going to set the start XY as 0010. Next I'm going to create an intelligent type. The name's going to be Q64AD, and I'm going to minimize the points to 16, and the start XY is going to be 0020. Next I'm going to create another intelligent type. This intelligent type is going to be Q64DA, and I'm going to set the 32 points to 16 points again, and I'm going to set the start XY to 0030. And that is all the parameters I'm going to set. I'm going to check for errors, no errors, and now I'm going to be creating the program I am going to use. I'm going to use a contact with the SM400 internal relay, which is the relay for always on, and I'm going to add a coil with an output of 31. This program is going to give me a value to log. Next I'm going to create an intelligent function module. My module name is going to be Q64AD. My mounted slot number number is going to be 2. I'm going to switch my channels from 4 to 20 MA to 0 to 10 V. There's nothing I'm going to change in the parameter. I'm going to change something auto refresh. My digital output value I'm going to make D100. And now I'm going to create another intelligent function module, which is going to be due64DA, and it's going to be mounted slot number 3. My switch settings, I'm going to change from 4 to 20 to -10 to 10. My parameters, I'm going to change only the first one from disable to enable. My auto refresh, I'm going to add D200 as my digital value. Now I'm going to convert and rebuild all. Now I'm going to use the tool logging configuration tool. First, I'm going to create a new data logging setting. I'm going to demonstrate trigger logging first. The data I'm going to set for logging is D100. The device I'm going to use as my trigger is going to be X2. I'm going to switch the operation at transition to run from auto start to start by operator, because I'm using the trigger. Now I'm going to write my data logging settings to my PLC. I'm going to change the target memory from standard ROM to memory card. After the data has been written to the PLC, I'm going to log my first data. I'm going to select the data logging name. Now I'm going to select start. Now my data isn't logging because I haven't met the conditions yet. It is waiting for a trigger, and when I switch the trigger, it logs my data. I'm going to stop. Now to view my data, I'm going to the logging file operation. I'm going to select log01. I'm going to select this file. Select this file. I'm going to say save to PC. I'm going to save it on my desktop. Here you can see the time the data was logged, the interval, the step number, the program it was logged from, the index and the value that was logged. Next, I will demonstrate how to do continuous logging. Firstly, I'm going to create a new program. I'm going to call my new program analog output enable. For this program, I'm going to create another coil with the Untitled SM400. I'm going to create a function block, the MOV function block. Now I'm going to connect the function block to the coil, add values to the block, D100 for the first value and D200 for the second value. Next, I'm going to register my program to the scan cycle. Now, when I go to my parameters, I will be able to see that there are two programs that are going to scan, and when I check, there is still no error. Now I will compile and rebuild all. And next I will go back to the logging configuration tool. Now I'm going to edit my data logging settings. I'm going to change trigger logging to continuous logging. I'm going to add D200 as a value I want to log as well. This specified logging operation needs to change back to auto start as well. And I'm complete. Now I will write this logging setting to the PLC. Now I'm going to log my data again. I select the log file, I press start. As you can see, the difference is that with this logging setting, I didn't need to trigger it. It started automatically and it's continuously logging all the data that is coming from the PLC. Now after it has logged some data for a while, I'm going to stop it. Now I'm going to go view the data I just logged. save to PC again. Now you can see the difference between triggered and continuous. Continuous logged data over a certain amount of time and logged all that data. As you can see, the different values and the amounts of data that was logged, where trigger only logged once when the trigger was met. Now I'll be demonstrating the log viewer. Here I can select the data file that I just logged, and then there will be graphs given to me of the data I've just logged with different settings. Thank you for watching the demo, and feel free to ask any questions after the webinar.